A global web application runs on Amazon EC2 instances behind an application load balancer. To optimize performance, a CloudOps engineer sets up an Amazon CloudFront distribution using the load balancer as the origin. After 1 week of operation, the engineer observes that the web server load remains high and the application load balancer is still processing the full volume of traffic. Which two of the following are likely reasons for this outcome? Select 2. A professional IT instructor explaining a certification exam question to students. Option A. The CloudFront distribution lacks the required origin access identity for the load balancer. Option B. The DNS configuration still routes traffic directly to the load balancer instead of the CloudFront distribution. Option C. The security group attached to the load balancer is blocking traffic originating from CloudFront IP addresses. Option D. The CloudFront distribution TTL settings, including default, minimum, and maximum, are all configured to 0. Option E. The target group is configured to utilize sticky sessions. This scenario tests your understanding of traffic flow and caching behavior in a distributed web architecture. When you introduce a content delivery network to sit in front of an existing application, you need to ensure that requests are correctly routed to the edge and that the caching policies actually allow objects to be stored rather than constantly refetched from the source. In my view, the correct answers are option B and option D. Let us look at why. Option B is correct because if the DNS record for the website still points to the load balancer endpoint instead of the CloudFront distribution, users continue to connect directly to the load balancer. This bypasses the content delivery network entirely, meaning no traffic is being offloaded and the origin remains under the same load as it was before. Option D is also correct. When you set the default, minimum, and maximum time to live values to 0 seconds, you are explicitly instructing CloudFront to perform a fresh validation or fetch from the origin for every single incoming request. Because of this, the cache becomes effectively useless, forcing the load balancer and the web servers to process every request instead of serving content from the edge cache. Now, why are the other options incorrect? Option A is incorrect because an origin access identity is a feature specific to Amazon S3 origins and is not used for application load balancer origins. Option C is incorrect as blocking CloudFront traffic at the security group level would lead to connection errors or access denied responses rather than allowing the requests to pass through to the web servers. Option E is incorrect because sticky sessions only manage request routing between the load balancer and targets. As an exam tip, always remember that for a CDN to effectively reduce origin load, your traffic must flow through the distribution, and your cache settings must allow objects to persist for a duration greater than 0. If the infrastructure does not route traffic through the edge, or if your TTL settings effectively disable the cache, your origin will not experience any performance or load improvements. Always verify your DNS routing and caching policies when troubleshooting traffic offloading.